My name is Phoenix. We are back with another CTF video solution. This time we are going to do our, let me count, 1, 2, 3, 4, 5, 6, our sixth CTF challenge, which will be Collatz Puzzle. The objective of our CTF will be to make a successful call to the callMe function, and we should be the deployer of the contract at the given address parameter. All right. So let us just quickly review what the contract is saying. The contract has defined an iCollatz iteration function in the interface. Then we have the contract where Collatz iteration is a function that is taking the value as n. It is checking if it's even, it will return n by 2, and if it's not even, which means it's odd, that means it is returning 3 times n plus 1. The function callMe takes an address, and in the assembly it is checking the exit code size. The required condition here is that the exit code size should be greater than 0 and smaller than 32 bytes. And this is the invariant that the contract is proposing, that it should not be exploited or it should not be used another way. Then it is checking P and Q, and after some function iterations it is checking if both of them are equal or not. But that is not our focus. Our focus will be this function, and to bypass this require function. In order to do that, but before we go, we will first define what is exit code size. So for those of you who don't know, every smart contract takes up a size into blockchain, and to counter that, any smart contract should not be take so much data into the blockchain that the whole blockchain comes to a condition of denial of service. A limit of 32 bytes was imposed. That means that each and every smart contract cannot go beyond 32 bytes, and that is the reason you see multiple smart contracts interacting with each other. So what this required condition is saying, that any smart contract cannot call this, and not an address, because exit code size for an address will be 0, and for a smart contract it will be small, greater than 32 bytes. So in order to create a smart contract whose size is less than 32 bytes, we have to actually go to our Ethereum and create a bytecode which will be less than 32 bytes, since we are working on EVM level. And so for this particular solution, we will actually refer to the solution given by, shout out to the guy Erhan Tezan, if I have pronounced it wrong, right or wrong, I don't know. So the solution will start by defining what will be the bytecode of the resultant function that we want to call. So in order to call this function, we need its function selector, or we can ignore that and just create a function signature with the logic that the author has provided. It's a wonderful logic. And if you want to know more about the EVM blockchain, what you can do is you can go here and play around with the opcodes of EVM. It will definitely help you in internalizing how Ethereum works on a molecular level, for a lack of words. So we need two codes. We need a bytecode that calls this function, and we need to create an initialization environment for our smart contract. So first we will develop this combinations of different EVM opcodes to get the resultant bytecode, and after that we will also produce an initialization code. Now if you want to know more about why do we need and why do we need initialization code at its first place, what you can do is you can refer the Ethereum yellow paper, and the yellow paper has this very cool explanation on why initialization of smart contract is required and how it takes place. You can definitely check it out. Now, when both of our bytecodes has been successfully found, what we can do, you can do this in both hardhat and foundry. You can just create an initialization code variable and runtime code variable, and you will create a transaction manually by adding initialization code, the runtime code with the 0x, because as you know, Ethereum starts with 0x. And then hopefully when all of this has been successfully executed, you will definitely be able to bypass this require condition and you will be able to call this function. Moreover, the initialization code is also making us the deployer of the contract, which is what we are aiming to do here. So this marks the end of this CTF challenge. This was a really hard one, and congratulations if you have successfully done it. Stay tuned for the next videos. Thank you.